Today we are going to see few more instructions here, more topics. These are previous ones. Now, here you can see we are having one hello contact and one output call. Okay, so here is a simple logic, right? When you give the input, the output will be on. When you make the input off, the output goes on. Okay, now so we are having two types of inputs. One is NO type and one is NC type. NO type means normally open type of switch. NC means normally closed type of switch. Right? If I'm using a toggle switch, in that case, right, toggle switch of NO type. So when you output a toggle switch, the input will be on, so your output remains continuously on until you make the switch off. Right? You don't need to hold the switch continuously on, right? You just make the switch on, it remains in on condition until you make the switch off. So we are having a push button. Another case is push button means it's a momentary switch, also known as momentary switch. So when you press the button, the signal is on. When you release the button, it goes off immediately, right? Means when you press and release, the input is going on and off. So when your input goes on and off, I want that output to remain on, right? I want this output to remain on, but that is not possible with the push button. What we are doing logically, okay, we have to add one latching, also known as holding, okay? And in our hardware, if we do this, so for that we are using auxiliary contactor or add-on contactor, okay? So that is in the hardware wiring, but here we are not using that hardware wiring, we are using a logical condition for that, okay? So how to use that? Select here, okay, before this NO, because we have to add one parallel function, right? So for that, go to the run branch and drag this and connect it here. Then select here at the corner of this run branch and add one contact. So here, what we are doing is for latching or holding concept. What happens here when I give the input? This output goes on, right? This output status logically we are using here in parallel to your start input. Okay, this is called latching. So here I save and let's see how it works. I download. Yes, go to run. Now I right click on this input, toggle bit. Now you can see when the input is on, this output is on. That output status is updated here in parallel, right? Now when I say push button, when I release, the input status goes off. So I right click here again and toggle bit. Now you can see the output is still on. Even if I do the input again, anything happening there? Nothing. Right? Still it is remaining on, means it is holding. So here it is called logical holding, okay, or also known as latching. Okay, latching circuit. Now, so to make this output off, we have to use one more input. For that, I go offline. So now select here, add one NC. And then I take this address here, drag and drop, and change the bit number to left. So why I'm using NC here? Generally, if you see in industry, they're having start and stop two push buttons. One is for start command, other one is for stop. For stop, we are using NC type of hardware switch. So in logic, in our PLC, we have to use NO. Okay, NO contact for stop. But here I am using NC because logically simulation we are doing, right? So logically we are thinking your stop button is also and no time. Okay. So here I'm taking this reverse. I save this, download. So yes, yes. Okay. Yeah. Right click, toggle bit. Output is on. Even if I release this, what happens? The output holds on. Right. To make it off, I output the second input. Right click, toggle bit. You can see it is off. So the output is also off. It's breaking. This logical continuity was from here. Okay. In parallel. Okay. Your input, start input that we are breaking using one NC. Okay. That depends on your hardware switch. If you are using hardware NC type of switch, then you have to use NO here. If you are using NO type of switch, then you have to use NC here. Okay. So this is about the latching circuit here. Now, so this is one method here. Another method for holding or latching, we're having more instructions are at the top of this block. You can see here. Okay. Latching, unlatching. Latch, unlatch means output latch, output unlatch. Here L means latch. Means you consider symbols here L and U. Now take the once, I take one NO, and I take one latch. So here what happens? Here your output is latched at the output call itself. Here it is, we are having a symbol L, right? So that is latched here itself. Similarly, to make it off, right, that is unlatched. So one input here, one output unlatched. So to unlatch this means to reset this. Latch means set, unlatch means reset. Okay, so that we have to use here. So I take the inputs here. Number two. Then take this output address here with number one. And the same address we have to take for the unlatch because which output we are setting or latching, we have to reset it. Okay, reset the same output. So here we are using this NO start stop, right, in series, but here we are using in parallel. Okay, in two different runs. Okay, let's see this how it works. Download. Yes. Okay. Now when I operate this input here, toggle bit. What's the status here? Output is on. Okay, because we are using the same output address here. The latch and latch both are showing on. Okay, so I release this one. Now you can see the output status are still on, holding. Right? Now to make it off, I have to give another input here. And now only I'm using here. Okay, and when I toggle bit here, this unlatching. This is for unlatching, which is unlatching your latch output. Okay, and then that means when you are using a push button, you're having these two options. Okay, by holding this parallel latching or by using this latch unlatch coils. Okay, these are the two methods you can use here for holding outputs. Okay, latching circuits. Now here we are using some addressing, right? I address, Q address. So in that way we are using many input and output addresses. But how you will identify which address are used for what command? Right? You cannot remember for long time. Okay, I'm having say 50-60 inputs and 50-60 outputs. So can we remember this input output addresses directly? Which input address are used for which command? Means start command or stop command for which motor one, motor two, sensor one, sensor two, right? That we cannot remember. So what you can do is you can use some symbolic names here. Okay, you can use some symbolic names. For that, right click on the address, select the address, right click on the address. Then you can see we are having edit description. Then you can give the name like start. Don't press enter. Okay, just give the start address and then say okay. You can see it's showing the name start. Similarly here, right click, edit description. So for stop, I'm not pressing stop, enter, right? Just say okay. Similarly for this output, right click, edit description, use some name like motor one. Okay, like here also I can use some names like sensor one, sensor two, and here some motor two, some others. So this way we can do the symbolic names for each addresses so that we can easily identify which address we are going to use for what command. Okay, you can easily remember. That's the advantage of using these symbolic names. Now, these are the basic symbols we are using here. Now, your switch will be off. Okay, in latch, what happens? In latch again, when I give the input here, this input is on, the output is on, right? I'm just showing once again, right click and toggle it back. So this is off now. The output is still holding, okay? And when I give this input here, on and off, toggle it back because you're using the push button. So you have to toggle two times, one for pressing, another time for releasing. Okay. Similarly for sensor here, when I do the input here, output is on. So when I release this, still you can see the input is off, right? So still your output is on. Similarly for this one, right click, toggle bit, right click, toggle. One is for pressing, one is for releasing. Means for push button, what is happening when you are pressing and releasing, right? So that is 1 and 0. So two times you have to toggle here. Always. Okay. So to consider as a push button. Okay. Now. Okay. So here these are the basic bit instructions we have here. Okay. Next one is bit. Okay. After user, we are having bit. This bit you can see the same instructions again. But one more instruction you can see is OSR. OSR stands for one shot rise. One shot rise means here we are generating a pulse. One pulse input. Pulse input means what? One pulse means when the sensor is sensing the object, your input goes on, right? When the object leaves, then your input goes off. Sensor input goes off, right? So that is called one pulse. The number of objects the sensor is sensing and it is going on, off that many times, right? So it is generating the pulses. But in some cases, if your sensor is detecting any object, okay, your sensor is remaining continuously on until the object is leaving. If your object is like a big box, okay, so when your box is coming in contact with the sensor goes on. And if it is like a 1 meter box or say small 10 centimeter some length, okay, so until that 10 complete 10 centimeter box is leaving, your input sensor is remaining on. Okay, so what we are doing is we are not taking it as a continuous input, but we take it as a single pulse. Okay, to generate it as a pulse, for that we can use OSR. Okay, for this OSR, we have to use a temporary address, not a I or Q address, temporary address. So what is the temporary addressing here is your binary address. You can double click open this binary file and simply drag and drop this first bit address. You can see B3 colon 0 by 0. Just drag and drop. Here it is storing the temporary status of this input. Okay, temporarily it is storing the bit this input status. Okay. So this download. So I'm doing this example using latching. Okay, using latching. So when I do a toggle bit, you can see even though your input remains on, okay, it has generated one pulse. Okay, so the output is on. Even if I release this, the output holds on. Okay, when I give this input, it will reset. But what's the difference, right? So before that also it was showing the same thing. Now, to understand it properly, what we do is I take one more run. I right click, open run. Here I double click X, I see, examine if closed. I can give a direct address. I column 1.0 by 4 space. You can give OSR. See what I'm doing. I'm just giving the OSR instruction name space B3 colon 0 by 1 address, then give space for output coil. Okay, for this normal output coil, not latch. Okay, I have to use OTE as a symbol. Okay, then space O colon 2.0 by 2. Then I press enter. You can see it is directly taking the instruction. OSR means one shot rise. One shot. One shot means a single inch. You can say 1 inch. On and off, one pulse. To generate one pulse. That example I'm showing here. Okay. So it download. Yes. Right. So observe here what is happening to the output. So when I give the input, okay, I'm selecting toggle bit. So just check the output status here. Okay, toggle bit on. See, one blink was there. Can you see that? Again, you see here. See, the output was just on and off immediately. It is generating only one pulse. Okay, that is your OSR. Okay, for generating a pulse. Again, you can see when I do the input, the output is going on and off immediately. Only one pulse is generated, even though your input remains continuously on. Okay, for that purpose, we are using this. For generating pulses, we are using one shot rise. Okay, so the number of times your input is going on, off, on, off, on, off. For that, you can use this OSR. I want to generate pulse. Okay. This is about OSR.